Okay, let's look at a couple of exponent properties for quotients or fractions, if you will. We had this property up here where when you have a product raised to an exponent, that exponent can be distributed to both parts of that product, or more if there's more than two parts. The same idea works with quotients or with fractions. If you have a fraction that is raised to an exponent, that exponent can be applied to either, or not either, it will be applied to both of those bases. So this is x cubed over, and remember when you have powers of powers, so when you have an exponent for an exponent, which is the case here, we multiply those. So we're taking 3 times 2, and that's giving us y to the 6th power. Again, why does this work? Break it down. This is x over y squared times x over y squared times x over y squared. We can spell that out all we want, okay? What we're looking at here are the shortcuts for these. So I have x times x times x. When we multiply fractions, we multiply straight across. X times x times x is x cubed. The y squared times y squared times y squared. If you think back to this, what we showed you up here, how if you're multiplying powers with the same base, you can add their exponents. That's what I'm doing here. 2 plus 2 plus 2 is 6. The shortcut here, there's 2 that are happening. If you have a fraction, you can distribute the exponent to both the numerator and denominator. And when you have a power of a power, or in other words, an exponent of an exponent, you can multiply those 2 values together. Here, when you have a quotient or a fraction with powers that have the same base, the shortcut is to subtract their exponents. So when you look at this, okay, you've got negative 3x to the negative 4th. Now remember that this negative 4 is only an exponent for the x, not the negative 3, right? Now we've got, if you want, you can put a placeholder here with the coefficient of 1 underneath that x. What we can do with, as far as the integers are concerned, if I can reduce that, I should. Since I can't reduce those, I'm not going to. That's just going to be negative 3. But when you look at these powers of x, I've got x to the negative 4th and x to the 1st. So if you want to take that off to the side, let's move down here. X to the negative 4th minus 1. We're subtracting the exponents. When we divide, we subtract our exponents if the bases are the same. X to the negative 4th minus 1 is x to the negative 5th. So this negative 3 divided by 1 gave me a negative 3. X to the negative 4th minus 1 was x to the negative 5th. So this would be our answer if we were writing it all on that same line. But remember, and there's another property that goes along with this, negative exponents in our final answer, if we want, we can write those in the denominator of a fraction. If there is no fraction, I can create one when the exponent is negative and move that down. Okay? When I move it, it becomes positive. If there's a negative exponent, let's say in the denominator, something like this, I can move that up to the top and call that y x cubed. So we're basically flipping its position relative to where it started. So since there is no fraction, there is no denominator, I would move it into the denominator if it's negative. But if there's already a fraction and it's negative, I can move it up.